Welcome back, everybody. I hope everybody got a quick little break in there. Before we get rolling here, I'm getting ready to pass it over to our first guest speaker, Greg Emerick. He's from Sentera. I'll let him kind of explain his company and his role more, but I would like to give a warm welcome to Greg and thank you for taking time out of your schedule to come in and talk to us today.
So first of all, thank you for the introduction. I missed it, so I'll make sure I just give a quick little bit of background about me and run through our technology and tell you a little bit about how our technology is being used for GIS applications, primarily in agriculture. And I'll scoot through a handful of applications, a little bit how the technology works, and then hopefully have a few minutes for questions at the end. My name is Greg Emerick. I'm a co-founder of Sentera. We've been around since 2014, the company has. Prior to Sentera, I graduated from St. Cloud State University with a degree in aviation with a professional flight emphasis. Was flying airplanes, flight instructing, flying charters, and ended up flying for the commuter airlines. And got involved in the technology world and honestly ended up leaving aviation to be more involved in technology. And back in 2011, I was fortunate enough to go out and buy a DJI drone and duct taped a GoPro to it. And in turn, started to use that technology to understand how it might be used. All my time flying around in airplanes, I got to see a lot of fields from the air. I've grown up on a farm, was around agriculture my whole life, and sort of those two things came together for me with this UAV applications. So as I go through things here today, I'll talk a little bit about us, what we're doing, and give you some more specifics about what that looks like. It's been an interesting road, to say the least. We've been through and seen a lot of different and interesting things, and I look forward to sharing it with you here today. So with that, I need to share a PowerPoint. And can someone confirm they can see this?
Yes, we have you, Greg.
Okay, super. Thank you very much. So a little bit about Sentera first to provide some context to our discussion here today. We were founded in 2014. We have a very interesting group of employees. Today there are 76 of us. Back in 2014, there were 12 of us. And early 2015, actually, there were 12 of us. In late 2014, myself and another co-founder, the two of us came up with a business plan from a company we'd left. The company had ran out of money. We were fortunate enough to generate some access to some intellectual property and to find some funding. And we're able to launch the company in early 2015 with a group of 12 of us. That team has grown to 74 today. The primary core constituents of our technology team all come from Lockheed Martin. That a lot of the technology we use today started there, and we commercialized it for agricultural applications. From there, of course, those sensors and software that's been developed, and then we've turned it and started to use computer vision, machine learning, and other data fusion and analytics from the multispectral sensors that we build to integrate those into unmanned systems, and then from there using that to help from a permanent row crop perspective produce analytics that are used in a whole host of different activities, and I'll go through a little bit of that today. We analyze, right now we're in the heat of the season for North America. We're roughly analyzing about 1 million acres of data per week. That continues to grow. And it's been a very interesting process, starting with a handful of us and not quite sure where we were going to what we're doing here today. We have thousands of active users around the globe. I'll show you a map of what that looks like here in a moment. And they're all using our analytics and sensing technology. And from there, helping them make decisions and produce more with less cost and fewer inputs to improve not only their economic outcomes, but also some of the sustainability and conservation applications. We have literally hundreds of farmers and ag retailers and crop inputs companies, along with state and federal organizations, engineering firms, researchers, universities. We work with a whole host of different customers. Most of it is focused on agricultural applications. From a footprint perspective, we have dealers in sort of the places you would expect that are easiest for us to operate in, but along with that, we have customers literally all around the globe. So it's made it a really fun and interesting road for us. The technology that we build, and I'll get to some of these other examples here in a moment, but the technology that we build, when we first were founded, it was really difficult for us to get good data out of the field and then be able to process it and drive context into the information so that we could use it. And everyone on this call has an appreciation for the fact that we have to understand where the data has been collected. And so we had to make this process simple for really a technology that many people had never seen before or associated with a little airplane and didn't really have an appreciation for the sensors, how the data should be used. And those were sort of the bigger issues that we had to address, okay? Along with that, of course, it's got to be inexpensive. It has to work. And then the data itself has to be compatible, not only with the tools that we built, but we believe with any other tools that could potentially ingest this data, like an Esri product, for example, so that it can be used in multiple different platforms over a whole host of different applications. So really the four cornerstones of what we do from a company, it's primarily sensors. The goal is to get good data out of the field and then be able to ingest it into a software tool that allows us to then perform analytics against it. And really the smallest piece of what we do is the use of a UAV. We use commercially available products when possible. We build fixed wing drones when the applications are necessary. But in the end, what we're trying to do, and the primary objective for us, is to get the sensor in the right place so that it's capable of giving us the best information. And we drive in as much metadata information as possible based on geolocation, altitudes, all sorts of other factors that might revolve around the use of the sensor and how the data is going to be consumed. So what's really important in across this entire process is the fact that you have to have good sensors and good measurement systems. And then from there, once you're able to measure this data and collect it accurately, then we have to be able to analyze it. And then ultimately making a decision is really what our objectives are as a company in order to drive efficiencies using our technology. So that, I don't mean it to be a commercial, if you will, but it's important for you to have an appreciation for what is necessary in order for this sort of technology to work. We don't believe that drones are a panacea. There are a whole host of reasons why different resolution, different coverage rates, and different data sets can add context to whatever's trying to be done. In our case, it's agriculture, it could be forestry, it could be a whole host of things. But it's important for you to have an appreciation that we started with drones and small sensors, but the data which we can consume and the way our platform works allows us to take in all sorts of other information that helps us. And we've gone from analyzing single images from a UAV to satellite data over a whole large area. And that might be imagery, but it also might be weather information. And now we can start to do some projections on helping customers make decisions. And an example of that would be A large area has just, in the central part of the US, as example, has had a weather phenomenon that affects agricultural crops. Well, people that are really interested in that might be an insurance company, and they're saying, can you help us identify where we should dispatch our adjusters most efficiently to make sure that we can collect the appropriate data? They'll use our systems to get there, but in turn, and so they have the higher resolution to actually adjust a claim, but in the process, they'll use some of these broader tools to help get to the right location. And of course, soils information, another topography, is also very valuable, along with machine information. It's getting information off of the implements that are there, and then results of what may have been generated. So an example of the data that would be collected, this is just a single sensor that provides an example of some of the things that we do from a technology perspective. This camera that you're looking at has two sensors on it. One side, it collects a color imagery, and the other side collects near infrared and red edge data. Those different bands can be separated through filtration techniques that we've patented that allow us to actually perform band math and then produce indices that can show things like water stress or water locations, disease or stress in the crop, and also perform other activities that might include simply counting and identifying where there's a plant or where there isn't. So we do build a whole host of different types of sensors. Some of them are very simple. They do very simple things. Others are fairly complicated and produce a whole list of different indices that the data can be collected and processed differently to give us different insights based on the information that's been collected through these multispectral sensors. These are a couple of examples. The one on the left, we've got that 9-band sensor there actually replicates a Sentinel satellite data collection system. However, the difference is, instead of each pixel being 20 meters, for example, the resolution would be measured down in, maybe 10 to 12 centimeters. So, and then we can put we can also put shortwave sensors on here as well to help us with real high frequency information that you wouldn't normally see on most of these small cameras that are being used for analytics purposes. The other one on the right, that's a research customer of ours. They're using the data to identify multiple different characteristics about a whole bunch of different plants, and they've asked us to build these sensors. Today, we work with a whole group of different types of customers and crops, and ultimately driving data in for our customers to help them make those decisions regarding what they're trying to accomplish. The customer categories are everything from the retailers themselves down to the actual grower, but everyone along the chain that supports agricultural production probably has some interest in understanding better data at the farm gate. And so what they are interested in trying to do is consume this data through tools that they may build. And so we've built our technology around the fact that they can reach in, pull that data out through APIs, and use that information for everything from research. So they might be down in small plot work and trying to identify where there are potential issues with any type of crop, really, to maybe understanding the sugar or protein content in barley across maybe 15,000 barley producers around the world that are using our technology to try and help them identify where they can, what they're producing, how they're producing it, and how they can improve their sustainability initiatives. So there's all sorts of traceability and other things that can be used. As long as someone can start with a GIS location, there's quite a bit of data that can be sorted and identified and used for those types of purposes. So, not sure what's going on here. There we go. There we go. All right. So these are some of the analytics that get performed. We will collect information through our sensors or through satellite data or those kinds of things, and then turn around and produce maps in a field based on what we can see. So the example might be, I as a corn producer planted 30,000 seeds per acre, but how many actually emerged? So we can fly, and if necessary, we could count every plant in a quarter section. It seems a little probably over collection and overkill, but it's possible. And in most cases, we will take an image, and one image inside of each acre, and provide a population count. And from there, that population information can be turned into a map that will then be a tool that will go to an agronomist or the producer to say, here, this looks great, or you have potential issues based on this location of the field. And so we can help with population counts. We can go out and drive weed maps. I'll show something about that here in a little bit to help save on herbicide use. Tassel counts. If you're a seed producer, it's really important to understand that you've harvested as many tassels out of the crop when you're doing certain production practices to produce more seed. And so customers need to know if those tassels are there, or if they have to remove them, or at what point did the tassel emerge? Maybe it's a research application. We do phenotyping, where we'll build 3D models. Again, all of these have specific GIS locations, or it might be replicated trials where they might have multiple trials. They're comparing different seed types, seed coatings, those kinds of things. And all of that information is then being consumed and then analyzed digitally and then pushed back out maybe through a CSV file or something like that, or a map that will say, in this location, this is the specific value of that particular plot. All of that data can then be consumed into other research tools or breeding applications or just simple agricultural practices. So the one thing I wanted to show here a little bit, I'll step back real quickly. From a satellite perspective, back down to the drone, again, we use all three of these different data products, and it might be simple color imagery, or it might end up being multispectral data. But in the end, it really comes down to what's necessary resolution. And so that's where we fill a niche with the drones, but there are other applications where we can take this other data in and do, because it's the more efficient methodology to collect the information that's there and necessary for us to help our customers make decisions. So here's a quick example. So we started this back in 2017. In 2018, we built some tools that use high precision GIS data along with machine learning, so that in turn we can map a specific location of a weed inside the boundary of a field. And from there, that field boundary has multiple shapes inside of it. And those multiple shapes are then the area that need to be sprayed. And that would indicate that there's a weed there, or a group of weeds there that can be applied or have a herbicide applied, but then in areas where there aren't any, the sprayer shuts off. So if the equipment is capable of that, we've had studies independently verified by universities where we've achieved anywhere from a 68 to a 93% reduction in herbicide use. And so it's really amazing, some of the things that we've been able to do. And of course, this technology is being consumed and continues to grow just because of that. One example here that we have is the one customer in particular flew 40,000 acres, sprayed only 27,000 of those acres. There was a 33% reduction. And again, it comes down to, is the sprayer capable of consuming the maps that are generated? And if it is, there's a very quick economic benefit to being able to reduce that. Again, disease and pest management, nozzle by nozzle control. We use this computer vision and machine learning techniques so that we can identify these locations. And then again, the customer can use the applicators in that way. Another interesting application is with permanent crops. So citrus, almonds, vineyards, those kinds of things. Those customers today look at this data a little bit differently than you would with a row crop. You've got an asset there that you might be managing for the next 30 or 40 or maybe 50 years. And so it becomes really valuable to understand the health of those individual plants instead of the crop as a whole. And so we have created tools that allow us to do that and actually go out, and the software is capable of counting and providing a digital location, or excuse me, a geographic location for each one of those specific trees. From there, then we can calculate tree height. We'll also calculate the size of the canopy, and then using multispectral cameras, we can also identify the health of each one of those individual trees. And so as you start to sort of follow the technology here, you can see where now it provides a much different perspective about what's going on in each one of these blocks of trees that are there and being produced. The value or the technology behind all of that happens to be the software tools that we use and point data, where we have the capability of driving information into each one of those individual GIS locations. And so that's how it's being consumed today. And then from there, a whole host of reports can be generated that are being used for everything from the true evaluation or valuations, excuse me, of property values, insurance requirements, or maybe insurance claims, optimizing application of water or nutrients, labor management. There's a whole host of information this is being used for today, and those are just a handful of the examples. And then lastly, I want to show a little bit about conservation, because we all talk about how we can use this in agriculture to drive economics, but and efficiencies, but there's also a ton that can be done from an agricultural perspective. There are many acres in the United States that aren't productive. And so if a farmer can identify those, there might be a high probability that they could actually employ the use of this technology to say, these parts of my field are not productive, and it makes more sense for me to be strategic about this and maybe take them out of production and put them into some sort of conservation program, for example. So we're using this to do things on a very small scale. And then from there, also trying to identify where there are opportunities to apply this on a larger scale. Okay, and there's information. This is an example out in western South Dakota, invasive cedars. We used NDVI data. Data was collected, and then a controlled burn was performed. And then after, excuse me, after the vegetation came back, or was given an opportunity to die out, I should say, then we went back in and the customer went back in and flew again, and they could see the efficacy of these burns and how well it worked, and if they needed to have perform additional practices. Whole bunch of reasons to do that. Most of it has to deal with grazing, and it's been an interesting tool. There are water indices that we can use, and actually growth in water that we can see if it's on the surface, not below the surface. But from here, you can see the NDVI. We started with a color image on the left. From there, we were able to generate some NDVI values and then put some topography in over the top of that. and it's quick and easy to see. This is just a demonstration tool that we had, or product that we generated, and you can see that all of the runoff that's coming out of that house right there is going right down that hill and straight into the water. So it was a real interesting way for us to sort of provide a way for our customers to show how the technology can be used. This is what this image on the left is actually a whole lot of water plants that are on the surface. We flew over this for the state of Minnesota, and we're able to identify the actual boundaries of where there's actual water, even though it's very difficult to see because just the one location is there. Different index, different application, but usable for that nonetheless for their applications. And then lastly, this is just an example of what we're doing. We've been working with the USGS and a couple of different conservation organizations to identify common milkweed. The image on the left is a color image, and the image on the right is a simple near-infrared image. And we use this information to help us identify the location of these and then count and take inventories for monarch butterfly habitat locations and documentation. In this case, there's a real concern that it's going to be going on the endangered species list. And so we've built this algorithm and developed the machine learning tool to be able to identify where there's common milkweed to help preserve habitat for the common milkweed for the monarch butterfly. So those are just a handful of things. I could talk for 2 hours about how we're using the technology. Well,
hey Greg, this is Tom. We have a couple questions from some of the members. What advice would you have for students interested in moving into this career area? Like possibly, what do you think is one of the most valuable educational tools that they can go for?
Sure. So my answer would be maybe twofold. So if a simple GIS degree where someone has an understanding of how to use some of these Esri tools, for example, ArcGIS or whatever it happens to be, is a really good start. I think when Sentera first got started, our focus was primarily in agriculture, but because of our heritage, we did do some things with law enforcement and defense applications, and some things that revolved around the use of our technology for infrastructure inspection, like bridges and that kind of thing. It just got to be too much for us to do in the sense that we were really focused on ag only. So those other areas, I know that there's a bunch of information or a bunch of opportunity in all of these areas. I believe, honestly, in the way we built our business, that there's probably more opportunity in agriculture than anywhere else. And the reason that I say that is because of the sensor and analytics development that's coming. There are only so many things you can do around a cellular telephone tower or a bridge. But if we can start to identify different diseases, different invasive species, different weed types, now you can start to do a whole host of different things with the data. And maybe I'll use weeds as an example. If you know what the weed is, maybe one herbicide doesn't work very well, but another one does. And so now you can start to differentiate and be really, really effective, and your costs become even less and less and less. So, and you become more effective. So there's sort of all of these areas that are available. I think ag happens to be provide a lot of opportunity. There's probably a 10 or 15 year horizon on what can happen with the analytics that will be performed. We work with customers around the world. There are all sorts of issues that are having to be solved. And it's not just on what we're doing, but how the data gets consumed. So if you have a GIS degree and understand the use of this technology, you might end up on the other end of the, and on the receiving end of that data. And that too, there's a real demand for people knowing how to apply this information in something as simple as getting the data into the controller for a sprayer and how to use that, or building a program for companies to do those kinds of things. The more specific we become, which this will, and the more autonomous these tools become, meaning equipment and other things, which they will, the more we're going to need those kinds of people helping us.
Greg, one other question. Thank you. That's fantastic. Do you have any sensors, Sentera sensors, that are in the mid and infrared spectrum?
Yeah. So yeah, I gave you just a small swath of examples of what we do, and most of the cameras that we build, not all, but most, are customizable as well. So if there's some specific need or specific application that you're trying to solve, or data that you're trying to acquire, in most cases, we're able to do that. Today, an example of that would be we built some sensors that are going on CubeSats for NASA and the University of Cincinnati, which is launching them and using them to identify algae in some large lakes in Africa. So there are some really unique applications that we have. Those are the kinds of things that I find pretty interesting, and I have a good time being able to do some of that stuff. But if there's some really sort of bread and butter, cookie cutter sort of stuff, we do that every day as well.
One other question, Greg, that we have, and I'm going to actually answer this from Pete Mariotto. I think I apologize if I said his name wrong. And he asked if Sentera works with universities as far and work with educators. We've actually been working at St. Cloud State University with Greg at Sentera for the last 2 or 3 years. The last system that we actually bought, the very last system was we got a 710 multispectral sensor from Sentera along with a drone setup, and they're helping us implement some of this technology because, like as Greg mentioned, it's really about what you do with the technology on the platform as far as integrating it and making decisions. And they've had years of experience, and it definitely helps us out knowing that we have a resource available that is working with this technology every single day in various fields across United States, across the globe. So I've used him and Sentera as a reference, and they're a fantastic company, and that's why they're one of our SMEs for the workshop.
I just add one thing to that, which might be helpful. Thanks, Tom. Many times our customers will come to us and they'll say, I'm using a hyperspectral camera. It's too much data, or we know that this is matured to something that we can do differently. And we're looking for a way to try and reduce the data load or get greater throughput, all those kinds of things. That happens every day with us. And we're working with probably, I think it's 58 different research universities around the globe that are doing these kinds of things. And that just, it continues to go further and further. And it's everything from disease to pests to all sorts of other applications. So the short answer is yes, we do. I think the second question that we get asked, if you're on the university side, is do you have, or education side, do you have any educational discounts? We do. We do that specifically because we oftentimes can do things where we're helping promote the same things together. We spend a lot of time in research environments and want to make sure that everyone's successful. So not only do we help you acquire the technology, but we also make sure you know how to use it.
So then Wayne had a comment as far as the sensors and covering the sensor topics. I believe Professor Richardson is going to go into a little more detail on as far as the bands, the sensor bands. If there's some questions regarding the individual Sentera sensors, we can definitely entertain that and then get in contact or give you some of the information on Sentera sensors. Let us know. This is much of this is a learning opportunity for all of us. I learn every day that we sit in and have these conversations as far as what can be done and what are the limitations. So you just, if you want to, you can unmute your mic if you have more, a more specific question. Definitely ask. Feel free to ask. We don't have to strictly use the chat. If there's a question and we're not, it's not being talked about, this is a great opportunity. Are there urban applications that you've worked with for the technology?
Yeah, it's a great question. I saw that one from Bob here. So the short answer is yes, in a couple of different ways. Urban forestry applications, there are applications for that. And many of the urban foresters are using this to document locations of trees and the health of those trees. And we've gone so far now that, speaking of educational partners, University of Minnesota is working on a sensor with us today. They've done the research, and we're building a sensor that will identify oak wilt and can discern between a healthy and a sick tree. And so, like I said earlier, that there's going to be, you know, another 10 or 15 year horizon on this technology. That's really what's going on today. That as soon as someone identifies an opportunity to solve a problem, it usually revolves around a sensor, and you know, if you're trying to do remote sensing, and then from there, we do a lot to drive context into that and to process the data. The sensors, some of them are actually capable of doing and performing the analytics on the camera. So you get a raw, instead of taking the raw data down, you actually get a processed image or a processed data set that allows you to reduce the data load and improve the speed at which you can understand what's going on. So yeah, the short answer is yes.
I just wanted to reiterate, if there's anyone that's in this group that's connected that might not have gone to lunch yet, and if you have any questions for Greg, I can't say enough of how helpful Sentera is as far as being able to have a company that is on the leading edge of UAS technology like this in our backyard, basically in Minneapolis. It's super helpful, but they have flown a number of applications in flight. So this is a great opportunity for agricultural or just an engineering drone technology. He's got, as Greg mentioned, and he's pretty modest, he has a number of years of flight experience, number of years of drone experience. So between the combination of that, it's a great opportunity to pick his brain if you still have any questions that he might not have touched on.
Greg, somebody asked if you've worked with the solar farm industry identifying hotspots and failing panels. So are you doing any thermographic work?
Yeah, so short answer is yes. Most of the thermal data that we collect is used for agricultural applications. It's interesting, plants get a temperature just like humans when they get sick. So there's a lot that we can do with that. We don't have specific, that kind of goes to that infrastructure side of things. We don't build a tool specifically for that, but there are some really great tools out there that can be used, and some of them are sort of off the shelf turnkey sort of things. So yeah, I mean, we've done some of that, but for the most part, our focus is mostly on agriculture.
All right, Greg, thank you. This has been fantastic. If there's no other questions, I think we'll transition it over to Tom Biller. I think he's on, and he's going to talk a little bit about the transition during lunch.
Yeah, that's great. Say one last thought. If you'd like, Tom, you're welcome to share my contact information with anybody who's interested, and send me an email. Love to connect, try and help you out any way that's possible. It would be great. So thanks. It's a real honor to be here. You guys have a great day.
Thank you again, Greg.
You're welcome.
Talk to you soon.
Okay, bye-bye.